Hi, everyone. My name's Varun, and I'm going to be talking about responsive and adaptive design, and also go into Flexbox module and give a brief overview about that. So I'm going to start with a bit of a historical context. For the longest time, web design was treated kind of like an extension to print design. The idea was to go from PSDs to HTML and CSS, and most sites were really fixed sizes and really static. If anything, we forced the user to resize their browser to view our design properly. And over time, there were a few enhancements here and there, but essentially, that's how we worked for the long time. Then in 2007, the iPhone arrived, and suddenly we had to think about another screen. But at the same time, we were saved from this idea of flexibility because there was a move towards building native apps and having m.dot domains. What this meant was we ended up with a completely separate version of our app, which was stripped down and worked different to what the desktop app was. So instead of having something that was flexible, we were building two different things. But then there were iPads. In 2010 was kind of a really interesting time. That's when Android was gaining popularity. But unlike the iPhone, there was no one Android phone. There were many Android phones. Each of them came in a different size, really different sizes, to be honest. And then with the iPad, we had a whole new category of devices, but at the same time, a whole new screen size we had to worry about. So clearly, we had a problem because we weren't just going to start with we weren't just going to start building websites that were targeted just at Android or just at iPad. We had to come up with a new solution. In May of 2010, Ethan Marcotte published an article on a list apart called Responsive Web Design. He laid out the problem that faced us as web designers, as well as a very specific method for solving it. His solution included three specific tools: fluid grids, flexible images, and media queries. Now, I'm sure everyone here is familiar with the term responsive web design, but I'll try to give us a definition just for the sake of semantics. And I like this one by Ravi Pratap of Mobstack. Responsive design is a technique in which the same HTML code is delivered to each device, but by tweaking the CSS, we allow it to adjust to the screen's form factor. And there's also something called adaptive design. But before I continue, how many people here have actually heard of this term? Raise a hand. So there's about like 50 different definitions of adaptive design just in this room. The term adaptive design was coined by Aaron Gustafson in his book titled Adaptive Web Design. The core idea that he was trying to get across was that of progressive enhancement. Now, progressive enhancement is this principle of starting with a firm foundation and adding enhancements on top of it. The basic idea of adaptive web design is not about the browser features. It's about creating an optimal user experience regardless of which device you use. But for some reason, majority of the web design community seems to have forgotten about this. They keep trying to equate adaptive design to all kinds of things. I've seen adaptive design used to describe things such as REST, which is responsive web design with some with server-side components, device detection, and adaptive layouts. If weird quirks in programming languages deserve this name, I think surely distortion of terminology in design does it too. So going back to this idea of progressive enhancement, there are three layers to progressive enhancement: the content, which is sort of the core rich semantic HTML markup; the presentation layer, which is the CSS and the styling; and finally, the client-side scripting layer, which is the JavaScript or the jQuery behaviors that you add. So if you go by this principle, responsive design is actually just a subset of adaptive design. It's one of the many things that you should consider about. And this is where two really smart people come into play. The first one is Brad Frost, who's a really amazingly talented web designer and behind projects such as This Is Responsive, Future Friendly, and Pattern Lab. And secondly, there's Jeffrey Zeltman, who's the author of Designing with Web Standards and also happens to have founded a list apart. Now Jeffrey argues that the purpose behind responsive design, that is the end result that we're trying to achieve here, should be separate from the specific techniques that we use to achieve it. And Brad put forth this idea that we should make the term adaptive design synonymous with creating a single web experience that modifies based on the capabilities of the device and the browser. So instead of using these two terms to describe specific techniques, we should really be striving to make them synonymous with the idea of giving the user the best possible experience on every browser and every device, and creating a single web experience. So instead of these two as separate competing technologies, I would like, considering these two as separate competing technologies, I would like to move forward under the premise that these two are really just two different names for the same idea. Which means when you go about designing your website or your app, you need to think about all three layers of progressive enhancement and not just the presentation. So we start with the idea of the content layer. I want to talk about certain specific techniques that will hopefully help you design for this single web experience. And the first thing to consider is mobile-first CSS. If you target mobile first, then instead of the browser having to build a layout, then check for media queries, and then reset the layout based on those media queries, you just start with the layout that you need to end up at. This way, on mobile devices especially, you have much more restrained resources and you can get better performance. And also pay attention to your markup. This is one part that people seem to ignore. Everyone focuses a lot on the CSS aspect of it, but HTML ends up getting really messy and ending up with all of these nested parent containers. So always try to use the least amount of markup possible. Avoid any kind of superfluous parent elements. And you'll most likely have to go through a couple of iterations and refactoring to achieve this, but trust me, it's well worth it. And this not only improves the performance of your app, but it actually makes things much more accessible. It's easier to add in things such as screen reader specific tags, or just allowing people with accessibility issues to just tab through your website instead of having to use the mouse. And of course, get the content out there as fast as possible. Compress and minify all the assets, CSS, JavaScript, HTML, and don't forget about images. No one ever complains about a website being too fast. And speaking about images, we've been using these techniques for a while now to get responsive, fluid images. But if you're building a content-heavy website, you also need to think about loading images that are suitably sized to the device that it's being viewed on. This, of course, comes with a server-side component to it. You need to have a system which creates multiple versions of the same image, and then depending on the resolution of the device it's being viewed on, serve the most appropriate image. So how do you go about doing this? The first way you could do it is using the picture element. So with the picture element, you basically wrap a bunch of source elements into the picture element. And then each one of these source elements has a source URL, which is the URL for the image that you're going to be serving, and then a media query. And then the browser is smart enough to pick out the most appropriate source URL and serve it based on the device. And then as you resize the window, then it'll update this image. But this is still an early spec and most likely to change, so what do you do in the meantime? Well, in the meantime, you can use libraries such as Mobify.js or Imager.js. This is an example of how Imager.js works. It's quite similar to how the picture element works, but with a bit of JavaScript involved. You place a div on the page where you want the image to appear. And then you set the data source and the width attribute. And then you run the Imager.js code, which is at the bottom there. So then Imager ends up replacing that placeholder div with a 1x1 pixel base64 encoded image. Then it replaces those 1x1 pixel images with the most appropriately sized image that it fetches from the server. And finally, a resize event is attached to the window, so when the user resizes their browser, then the image element just updates. And lastly, on the content side, there is server-side templating. The server detects the device which is making the request and offers distinct templates based on its type, and in some cases, distinct CSS too. This definitely helps with performance because the client has to download less data. It improves page load times and even enables more customization. However, it comes with this added headache of maintaining multiple code bases. A lot of times teams are forced into this because of organizational issues or you're dealing with legacy code. I personally prefer to use a single code base, but it's one of those things where you just have to make a call based on what works best for you and for your unique situation. So next I want to move on to the presentation layer, where we deal with things such as the layout. There's generally two approaches to the layout. First one is adaptive layout, where you use fixed breakpoints, and then the content resizes at those breakpoints. The drawback of this approach is that on certain devices, you end up with a big bezel on the side and end up wasting a lot of screen real estate. Or you just end up supporting a lot of breakpoints, which is why generally people are moving away from this approach. To be honest, there aren't that many good reasons to be using adaptive design. You might be able to get away with it if you're building like a personal site or a throwaway one-time site. But one of the big reasons why you might be restricted to adaptive design is because of ads. Ad services are pretty slow to catch on, and you might be stuck with a service that's still serving fixed width ads. But there are ways around this, and I have a couple of good examples here. On the right, there is the Verge website, the new responsive version of the Verge. What they do is they start off with two ads, one at the top of the page and one on the right-hand side. And then as you reduce the screen size, they start taking them away. First the top one, and then the one on the right-hand side. So you end up with no ads on mobile, which might not be the most ideal situation. So the other way to deal with it is on the left-hand side, which is an example of a responsive ad that Zerp demoed. So in this case, you move from a separate column ad going into inline as the screen resizes. The other kind of layout is responsive layouts, and these are based on percentages of the current window size. They flex as you resize the window. I would definitely recommend using this over adaptive. So moving on to responsive typography, the most legible typography contains between 45 and 75 characters per line, and your goal really should be to achieve this through your layout. You can do this using plugins such as FlowType.js, which just handles everything for you. All you need to do is make this call once, and it just resizes this type every time you resize the window. The other way to do this is using media queries and setting specific pixel values or M values. So in this case, you follow the same pattern as adaptive layouts, and you create breakpoints, and then you just resize elements at those breakpoints. One other way to do this is using viewport units. The end result that this provides is actually quite similar to those JavaScript plugins. You can use using the viewport units, you can make sure that the text always fits into its containers width. And then, of course, the containers width is determined by the viewport size. So when you resize the window, the font size changes automatically too. Most people aren't really familiar with these viewport heights, so if you've never heard of them, I would recommend that you check it out. They have really good support, and you can actually use them in production. And then the last method is using the rem units. So rem is pretty similar to M, except everything is referenced from the root element. That's the HTML element and not the body. Mark Otto's personal site actually is a great example of this. All he does is sets the font size explicitly twice on HTML and then a second breakpoint for mobile. And then all the other fonts just automatically update. So in this case, the H1 font size, that's 2 rem, will actually be 42 pixels when the width is less than 48 ems, and 32 pixels when in any other case. Next, I'd like to talk about responsive tables. Tables, for some reason, were limited to desktop for the longest time, but there is a push towards making them responsive so that you can actually view this data on mobile too now. There's two approaches to this, squishing and grouping. On the right, there's an example of squishing. So essentially, the columns just keep reducing in size, and the font size keeps reducing to keep all the data still in a tabular format. This works if you have smaller data where it's mostly numbers, and you can still get away with smaller widths for the columns. The other way to do it is on the right-hand side, where you actually keep reducing the column size to a certain extent, but then you switch to grouping at lower screen sizes. So you grab an entire row of the table and turn it into a separate container, and then show the titles for each and every one of those groupings. And this actually ends up working quite well. And finally, from the presentation layer perspective, optimizing animations and optimizing them everywhere. People seem to forget about optimizing animations on mobiles, and I routinely come across websites that will just completely crash on mobile Safari or mobile Android, or mobile Chrome, sorry. So spend some time learning and understanding what actually happens in a browser. Get familiar with profiling tools in Chrome. It's great when it comes to figuring out what's causing bottlenecks. It really helps you understand what's happening during your animation. And you need to learn about what triggers relayouts, what triggers repaints, and how to leverage the GPU. Building animations that run smoothly on all platforms is actually pretty hard, and there is no secret to it. You just have to pay attention to figure out what's actually causing these relayouts and what's causing these repaints, and minimize them. This is a topic in and of itself, so I won't really get into too much detail here, but there are some great articles out there if you want to research deeper into this. And then the last layer is the client-side scripting. The BBC dev team runs this blog called Responsive News. I would recommend everyone check it out. It's really great. They have some detailed case studies there, and some of the solutions that they come up with dealing with responsive design at a large scale. So they proposed this idea called cutting the mustard, which really goes back to this idea of progressive enhancement and focusing on content and not the browsers. So essentially what you do is you test for a bare minimum requirements in a browser required by your app. So instead of targeting IE for desktop specifically, or older versions of Chrome on Android, you just lump all the browsers together and you just test to see whether these features are available or not. So this specific code is something that they use in their site, and obviously you would have to come up with a similar test pattern based on what you're trying to do. And then if the test passes, then you bootstrap your JavaScript application. Otherwise, you fall back on serving only static content. It's a really powerful methodology for web developers because you start with a firm foundation and then you add enhancements on top of it. But at the same time, in the last 2 years, JavaScript frameworks have come into play, and a lot of the app logic has actually moved to the client side. And that's where the browsers have become better at it too. So this, to a certain extent, becomes less relevant because the browsers are getting better at parsing JavaScript and becoming more efficient at it. So you don't have to worry about these on modern browsers at least, but for older browsers you can, and if you're building a large-scale application, then you still have to worry about this aspect. I also want to touch on this idea of migrating code bases. A lot of you might be in this situation where you have to port a legacy app to responsive design. And BBC, again, has a really interesting approach to this. So what they decided to do was build a separate mobile version of their app. It's responsive and everything, but it only has the core experience and doesn't have all the features of the desktop app. They see that as planting a seed. So when it comes to adding a new feature, it's added to the mobile site first, and then shared with the old desktop site. And then over time, as you're working towards bringing all the features of the desktop site to the mobile site, you end up with a completely responsive site. And at that point, you can just abandon the old desktop site, and you have a responsive site that works everywhere. So that's pretty much all I had to talk about for responsive design and adaptive design. Next, I want to move on to a new layout module for CSS called Flexbox. So Flexbox lets you arrange elements on the page such that they behave predictably. That's the official definition, so that probably means someone thought that the box layout was actually behaving in an unpredictable manner. And this works great even when you're trying to move the layout around for different screen sizes. So we should start by covering some terminology first. the Flex layout always requires a parent container. This parent container is called the Flex container. And it has two axes, the main axis and the cross axis. And you can align your content along these two axes and use it to define really complex layouts. The Flex container also had, and lastly, each item or each child that's inside the container becomes a Flex item. Can you actually use this? Desktop support doesn't go as far back, but it actually has really great mobile support. At Wrangle.io, we end up using Ionic framework a lot, and Ionic completely depends on Flexbox. So we actually have a couple of apps running in production that are using entirely Flexbox. So I'm going to share a few Sass mixins here for Flexbox. These were pulled from the Ionic Sass library and are based on Philip Walton's solved by Flexbox patterns. The first thing you need to do is set the display type of the container, and that's using this mixin. You'll notice there's like a couple of versions of WebKit and a couple of versions of Mozilla tags there. The reason for that is Flexbox changed its spec recently, so some of the older browsers actually support the older spec, and the newer browsers support the newer spec. So that's why using mixins in Sass or less actually makes sense, because otherwise you end up with all of this markup that you have to keep a track of and have to write constantly. So once you set the display type to Flex, you can start thinking about how to lay out the items inside. So what you do is actually set a lot of properties on these Flex items which help you define the layout. And specifically, there are 3 properties: grow, shrink, and basis. Basis kind of lets you set the initial size of the item. So this is the size of the item before all the space is redistributed based on the Flex layout, and then these items are resized. So in this example, the Flex container has a width of 100 pixels. And then the first item on the right-hand side has a basis of 50 pixels, and the other 2 are set to auto. So in this case, the first item will fill half the container, and then the other 2 will just automatically size to fill the rest of the space. The second property is grow. So grow dictates what amount of available space inside the Flex container should the item take up. Again, in this example, you have basis set for 25 pixels for the first and the last item. And then for the middle item, it's set to auto, and grow is set to 1. Grow is actually the first property there. So for the first and the third element, grow is set to 0. And for the second element, grow is set to 1. So when you set grow to 1, what it'll actually do is expand that element and fill all the remaining space. So you don't have to worry about figuring out. Normally, if you do this with CSS, you would have to use JavaScript to figure out how much space the 2 elements on the sides are taking up, and then subtract that from the width of the parent container, and then resize the middle element to fill up all of that space. You don't have to worry about all of that stuff. If you just set this as CSS, it automatically fills up. You can also use this to set ratios so that one item can grow 3 times bigger than the other one. So if you set the grow to be 1 to 1, the second element will actually grow twice as bigger as the other 2 elements. And then the last property is shrink. Shrink determines how much the item will shrink relative to the other items if there isn't enough space. For example, in this case, the container again is set to 100 pixels, and all the items are set to 50 pixels for their basis amount. So clearly there isn't enough space for all of them to fit in there. So the layout module will depend on the shrink values that we set. And by default, all shrink values are set to be 1. But in our case, we set the shrink value to 2 for the middle element. So what this will do is the middle element will actually shrink twice the amount as the other 2. So its width will actually be half the size of the other 2. You can also set the direction of the flow. If I go back to the initial slide, flow is set along the main axes and the cross axes. So you can actually define whether your layout should follow a column pattern or a row pattern. So this way you can actually build layouts that go from columns to rows which is quite similar to the grid framework libraries that we use right now. And you actually have to use an entire CSS framework for that, but instead now you can just use built-in properties in CSS to do that. And lastly, you can also do alignment. So alignment kind of lets you define where this item should be aligned within the parent container. And alignment happens along the cross-axis. So to vertically center something, all you have to do is call align self center. That's it, which is kind of crazy compared to what we have to do in CSS right now. And finally, I want to share an example of kind of things that you can do. So this is a pretty basic layout that you end up using for most mobile apps. There's a menu up top and then tab navigation at the bottom. So this kind of demos that you can actually nest Flex containers too. In this layout, you initially nest containers in a column layout. So the navigation up top, the main content, and then the navigation at the bottom are set to align along the cross axes. And then within the navigation up top and the navigation at the bottom, you turn those elements into a container again, and then align items along the main axes. And then the middle content is just set to expand vertically so that you can actually still scroll within that content. So you can actually have a scrolling item in there or just a fixed width item in there. So I would like to end my talk by saying that there is no magic bullet to responsive design. All the choices that you make depend on your specific set of constraints and your specific project. What you need to do is really try to understand what all these techniques out there are available, and then try to come up with the best solution that works for you. You simply have to test and iterate until you find the right mix. If you're building a cross-platform mobile app or large sites, front-end regression testing is an absolute must. Thank you. So you can find me on Twitter at Winker versus Bex, and check out my blog at varun.ca. And you can find Wrangle at wrangle.io. Thanks. And I'm here to take any questions if you guys have any questions. Sure. In most cases, it doesn't really matter. The only time, in current time, the only time it matters is on really old devices. So if you're going to be supporting a lot of apps in, say Asia or Africa, where people are still using old Nokia phones, then you need to start worrying about that. But in most other cases, you don't actually have to worry about it too much. Any more questions? Right. Thank you, guys.